Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concept of sinusoidal models. So as per the problem, a Ferris wheel has a diameter of 520 feet and the center of the wheel is 270 feet above the ground. The wheel makes a complete turn every 8 minutes. Write a cosine function to express the height h in feet of a passenger on the wheel as a function of time t in minutes, given that the passenger is at the lowest point on the wheel when t equals 0. So the first step we should do is to draw a diagram because that will help us visualize the problem. So we should start by drawing the Ferris wheel. So we'll draw a circle, and that's the ground level. Now we are given that the diameter of wheel is 520 feet. So this distance from here to here is 520 feet. So from the lowest point on the wheel to the highest point on the wheel. Now the radius of the wheel, so the center is here, so the radius of the wheel will be equal to half the diameter of the wheel. So half the diameter will be 520 divided by 2, which is equal to 260 feet. Now we are also given that the center of the wheel is 270 feet above the ground. So that means the distance from here all the way to the ground is 270 feet. So based on this diagram, we can see that the lowest point on the wheel is 10 feet above the ground because the distance of the center of the wheel from the ground level is 270 feet and the radius of the wheel is 260 feet. So we'll do 270 minus 260, which is equal to 10, and the unit is feet. So this distance here is 10 feet. Now we have to write the cosine function for the height of the passenger. So we'll start by writing the general equation of a transformed cosine function. So the general equation can be written as now different teachers use different letters instead of A, B, C, and D that I have used in this equation, but the idea is the same. The letter itself does not change the steps or the meaning for these letters. So we have to find the values of A, B, C, and D to write the equation using the cosine function. So the first thing we can do is identify the minimum height and the maximum height of the passenger riding this wheel. So the minimum height will be equal to 10 feet and the maximum height of the passenger will be equal to 10 plus the diameter of the wheel, which is equal to 530 feet. Now we can use these minimum and maximum values to calculate the amplitude and the midline of this wheel. So let's start with the amplitude. So the formula is maximum minus minimum divided by 2. Now we can sub in the values. So the maximum is 530. So I got 260. So that's the amplitude of this wheel. Now we can calculate the d value, which also represents the midline or equation of axis. So for d value, the formula is maximum value plus minimum value divided by, so 530 plus 10 divided by 2, which is 540 divided by 2, which is equal to 270. Now we can calculate the b value, which can be calculated using the formula b equals 2 pi over the period of the motion of the wheel. So in this situation, period represents the time it takes for the wheel to complete one full rotation, and that's given as 8 minutes. Now since the unit of t should be in minutes, so we'll use 8 as the period, which can be reduced now to pi over 4. Now we have to find the c value. Now c value represents phase shift. Now as per the problem, the passenger is at the lowest point on the wheel when t equals 0. So that means the passenger starts the ride at its lowest point. So for a cosine function, if the graph starts at the lowest point, so we can use the a value as the negative of the amplitude and the c will be 0. So the a value will be equal to negative 260 and the c value will be 0. Because when the minimum point lies on the y-axis, that means it's a case of vertical reflection or the reflection over the x-axis. So that's why the a value is negative and there is no phase shift because the minimum point is on the y-axis. So now we can use this information to write the equation. So h at t equals, so negative 260, so that's the a value, cosine, b is pi over 4 times t, and then plus 270. So this is the cosine function equation that represents the motion of this Ferris wheel. So these are the steps you have to keep in mind to solve a problem like this one. So it's important to understand that whenever you have to use cosine function for a graph that has the minimum point on the y-axis, or the starting point is the minimum point, so we can use the a value as negative, so as a negative cosine function, and the phase shift will be equal to 0. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.